Hi, everyone. As Jen mentioned, my name is Naina Raisinghani. My pronouns are she and her, if anybody meets me later. And I'm a software engineer at Google, and I've been there for about 3 years doing everything web-related. I spent 2.5 years on the Chrome rendering team, and the past 4 months-ish on the accelerated mobile pages project at Google. Now, to why I'm actually here. I'm thrilled to be here presenting my first ever talk about something that's very near and dear to my heart. Thank you. I'm excited too. Woohoo! And what is this? It's Houdini. And Houdini is a set of APIs that gives you the ability to extend and experiment with any part of the browser's rendering engine. Now, before I go into the content, if for any accessibility reasons you need to follow the slides along on your own local machine or want to dig up some content later, the slides are at bit.ly/Houdini-dinosaur. Yeah, that's about the only joke you'll get from me today. Now, before I explain what Houdini really is and what benefit it gives developers, let's try and understand the problem that Houdini is trying to solve by understanding the standardization process with specific regards to CSS in 2018. Now, in an ideal case where you want to add a new CSS property or add a new value to an existing property, you'd go through some of the following stages. First, you'd start up with an idea. A browser rendering engine, a standards developer, framework author, or web developers who are really tired with the current status quo will then have an idea that can change this. Now, after they've thought about this idea, the standards committee then sits down to specify an algorithm and an expectation about how this new property or CSS value will actually perform. Now, once the spec is relatively sane and stable, all the browser engines will go back and will start implementing this property, and then voila, framework developers and framework authors, web developers can use this and make the website more performant, more robust, more speedy. Now, who here can say things have gone easy in the web development world? Good on you, eh? Now, the reality flow is a little something like this. Now, while the ideation phase for new CSS properties or values is theoretically democratic, the lack of insight into standardization process plus the actual burden of attending conferences and standardization meetings means not everyone can take part in it. A lot of committees are actually making an effort to make this process more democratic. They're having teleconferences, they're funding experts on topics to come in and talk about and really give their experience in. But this is still a work in progress. And Houdini helps this by moving the ideation phase away from standardization committees. Furthermore, the current standardization system is really bogged down with just the sheer number of features that web developers are clamoring for. Some of these include Flexbox, CSS Grid, Conic Gradient. Now take CSS Grid, for example. While the spec here did hit stable fairly quickly, that's not the norm, but the exception. And in fact, with CSS Grid, some parts like Subgrid are still contentious and haven't shipped. Now, let's see what skip a slide there. Let's see what problems the implementation has to suffer. Now, browsers, when they go back and implement things, have their own problems. Each browser has limited human resources against which they have to prioritize features. And then they have limited data about what's actually needed by web developers and what will make the experience much better for them. An example of this is Conic Gradient, like I mentioned earlier, which the web developers have been clamoring for. There's a very well-used polyfill out there, but most browser rendering engines haven't gone and implemented it. Now, another thing to really think about here is browsers are always fighting technical debt. Every time they choose to add a feature to an already existing set of, to their already existing code base, they're working with a really unwieldy code base, which just leads to an imperformant, non-interoperable implementation in many cases. Now, when web developers do end up going to use this, they have to take on this technical debt in their own format. They have to hack around their websites to make it more performant and make it interoperable somehow. And they then pass this technical debt onto the end users with slow, memory-consumptive websites. Now, so how do we go about tackling this problem of, while making sure that we add primitives to the web by following the most democratic possible way? Because that is what we enjoy about the web. It's democratic and it's easy to use, as well as it's easy to consume. Now, we do so by following the extensible web manifesto. And the details of this are going to be linked in the appendix for the doc. But it basically suggests that browser rendering engines provide low-level APIs that the large number of web developers and their community can then build on to explore new ideas and new primitives. Now, why is this solution something that I'm propagating today? Because first of all, it allows browsers to go back and really implement a contained and a secure surface area so that developers can trust that when they use an API, it's been well thought out, it's safe and secure. It also allows browser rendering engines to really spend time optimizing their core rendering engine and make performance improvement there. In the end, this helps web developers by giving them performance gains without them having to actually go and edit their code. It also directly frees up the standardization process. In the case of the W3C, where a lot of specs are worked on, we have the WICG, which is the Web Platform Incubator Community Group, which is basically an area for everyone to come and suggest ideas, to talk it through, to work it over before they feed this into the formal standardization process. And polyfills like Houdini, and ideas such as Houdini will help web developers polyfill new ideas before actually taking them to standards committees. And this also then takes us back to the whole idea of making innovation more democratic. People can work on ideas without having to go to a standards committee, work it through, gather data that that the use case that they're trying to fulfill is important, and then take it to the standards committee, which has this data already, to then prioritize work against. Now that we've seen what benefits Houdini and other such APIs have to offer, let's actually walk through some of the cool APIs that make up the Houdini effort. Now, most of the Houdini APIs are going to be based on something called Worklets, and that's what makes up a lot of the Houdini magic in this case. Worklets are a lightweight interface, much like web workers, and they allow you access into low-level parts of the rendering engine. Worklets, unlike web workers, however, are restricted to very specific use cases, and you can't just perform arbitrary computation in them. With Worklets, you can run either JavaScript or WASM code to do stuff like graphics rendering, in the case of custom paint, which I'll talk through, or audio processing, as an example, is Audio Worklet. Now, how do you actually go about writing a Worklet? From inside the browser's context, you'll have a JavaScript file where most of your Worklet code will reside, and you can add a module pointing to that Worklet file. And then on the JavaScript end, you'll register this Worklet with a class that basically has a process function where you have access to a limited set of arguments, and this will differ from Worklet to Worklet, and then you can work on this to actually do some some manipulation. Now, the first example of a Worklet is the custom paint API. Now, the paint stage of CSS is responsible for painting the background or the content or the highlight of a box. Custom paint allows you to generate an image wherever a CSS property like background image or border image expects an image value, actually. And it will then paint the box in response to changes in size or computed style information. So let's again take a little bit of a look at the code samples. Now, just like I showed you for Worklets, you would point to a Worklet file, which is in this case mypainter.js, and then instead of setting your background image to a URL or a gradient, you would point it to a paint Worklet call, which is going to be found in the other file over. Now in mypainter.js, you will register the paint function, and you'd have a paint callback. Now the paint callback takes in 3 arguments. The first is context, and for anyone who's worked with context rendering 2D as from the canvas element, it's basically working the same way. And for those of you who've never worked with canvas rendering context 2D, I have some resources in the appendix section that you can take a look at, because that's how I learned personally. Now, what did I actually do with custom paint? Has anybody here used Instagram Stories type? Okay, has anybody used Instagram Stories? Perfect. They have a type mode where you don't just have to upload pictures, you can also upload your wild thoughts. So if you actually follow me, you'll see some of my very random thoughts. But basically, yeah, the background is being rendered here using a custom paint Worklet, and so is the button that you're clicking on. If you use Instagram Story type, you can also change the font as well here. The demo can be found at bit.ly/roar-paint, and you can play with it. Here, the background's pretty simple. It's a linear gradient, but you can throw a conic gradient in there. In fact, you can use the polyfill for conic gradient in here very easily. Now, what are some of the benefits that custom paint has to offer? Developers currently use a large amount of DOM to create some visual effects. Instead of using additional divs that you then display none or change the background of repeatedly, you can just draw to the background image of a constant element, reducing the amount of DOM that you use by a lot. You also ship reduced code. A solution using Paint Worklet is smaller in terms of byte, but of course there is a trade-off. Your paint code will run whenever your canvas changes size or computed style. And since Chrome has shipped custom paint, they are working on moving this off the main thread and off the main thread so that we have reduced jank even with longer running Paint Worklet threads. Next in the agenda is properties and values. Now, currently, we have something called custom properties, which allow developers or authors to assign arbitrary values to an author-chosen name. And then you use a var function to then assign this value to a CSS property. And we'll see a demo in a bit. But properties and values will then extend this idea of custom properties by giving you two more functions. First, it allows you not to just specify a type for your variable, but also define the default behavior as well as the inheritance. And then it allows you to animate these custom properties using animations and transitions. Let's take a look at what this would look like. Now in this case, you have a custom property called --my-color, which has been set to green, and then you override it with a URL. But you want to pass this into a color property. Now URL isn't a valid syntax that a color property accepts, but it's overriding green, which means that when you actually compute the color here, it'll throw and be an invalid one, and you'll default to color's inheritance behavior, which is take on the parent's color. Now that's not what we really wanted. We wanted green. How do we fix this? We make sure that we register the property and say that it's going to follow the color syntax, and then we give it an initial value of black, blue, light golden rod, yellow, whatever suits your fancy. This means that as we then go parse through this, we'll see that URL is not a valid color syntax, and we'll ignore it, which means that my color will get the correct value of green in this case. Now, as I mentioned, you can also animate or transition over custom properties and values now. So here you have --stop-color, which has an initial value of black and follows the color syntax. We set it to be deep pink, and then we transition it over to deep sky blue when we've assigned it to the background property, and we have a linear gradient from white to the stop color. So you can see a demo here. As you hover over it, it changes from pink to blue. Now this is a suite of demos that imvideo.me has made, and they have a whole bunch of Houdini demos there that I would really encourage you to check out. If the link down there is a bit longer to remember, it's bit.ly/raw-properties, and then you can look at the other Houdini demos from there. Now, some of the benefits of properties and values, like I mentioned, you can perform transitions and animations over custom properties, which isn't something you could do earlier. You can also combine this with custom pane as well as custom layout, which is something I'll talk about in a bit, to really make your own CSS properties or values and really play around with them. It also makes theming so much more easier, and you have to write much less spaghetti code. The next thing is emojis. Type2M. Type2M stands for the CSS typed object module and expands the current CSS object module by adding types, methods, and much saner manipulation of CSS values. For anyone who's gotten strings and edited them in JavaScript, this gives you a much saner manipulation of CSS properties and values. Let's take an example. Now, CSS currently already has an object module. In fact, anytime you go and change the style attribute or a specific property on the style attribute, you're interacting with it. Now here, I've set the opacity to be 0.3. It's a number. However, when I ask the browser back for it, and I check the type, it's a string. That's because the browser is forcing everything to a string to give it back to you. Now, instead of using element.style in Type2M, we would then go and use element.attribute_style_map. Attribute_style_map is a map, so you can use any kind of map-like features, get, set, keys, entries, whatever suits your fancy. And here you can go call the set operator and set the opacity to 0.3. And then when you get it back, it's actually a number, which is great because that is something you can work with. You can go increment it by 0.1 as you increase the opacity, and you don't have to go parse a string again. You can also you don't just have to set it to a number. You can set it back to a string, and we'll give you the correct value. Opacity will always be a number. Display will always be a keyword, etc. So here you can also use, I think it's hidden behind the ferns here, but you can also use css.number to set it to a number as well. And this is a helper function provided to you by Type2M. Now, computed style values are exactly the same as well. Currently, you would set an elements property and then go get computed style an element and get its opacity. Again, the value would be a string. But now you can go element.computedStyleMap and then call the get function with the property, and you'll get the correct value with the correct syntax that you expect. Now, some of the benefits that Type2M has to offer, there's fewer bugs because of the string manipulation that you have to perform, which means arithmetic operations and unit conversions are so much easier. Now, since we don't have to deal with strings, performance is much easier. Every time you as a developer query a CSS property or a CSS value in JavaScript land, the browser, which has stored it as a typed object, is converting it to a string to pass to you. You then manipulate, interpret, slice, dice kind of things, perform operations on the string, and then send it back to the browser, only for the browser to have to set it back to a typed object. By getting rid of all of this string manipulation, early benchmarks have shown a 30% reduction in performance 30% reduction in the amount of time taken to manipulate strings in JavaScript. There's also much better error handling. Type 2M, because it is classes and objects, gives you much better feedback when you're actually when you're messing things up, or when you're setting a URL to a color, when you're setting a URL value to a color, for example. It'll give you much better console errors, which makes development much easier for you. Now, here is a demo of the actual benchmarks that we ran. It uses benchmarks.js, and you can see that there's a 30% reduction in round-trip editing of CSS in JavaScript. You can access this at type2m-perf-test.glitch.me. Now, the next up is animation worklet. I wanted this to be a poo emoji. Couldn't find one. Don't have an iPhone. The animation worklet is a new primitive that creates scroll-linked and other high-performance animations on the web. It gives you the richness of scripted animations, so stuff that you would write in response to a request animation frame, timeouts, or async scroll events, with the speed of accelerated CSS transitions and animations as you would identify them in CSS land. Now, much like custom paint, to actually write an animation worklet, you would have to add a module which references a worklet file. And for those of you who've used web animations, worklet animations follow the same syntax. You have to give it an ID, an element that you want to target, as well as the keyframe, so what kind of animation you want to take place, transforms, opacity, etc. And then if you want a scroll-related animation, you provided a scroll timeline. Now, on your JavaScript, on your worklet end, you would then have a constructor where you can set some properties as you see fit, and then the animate callback, which actually determines what kind of animation is going to take place. So what kind of speed you want it to be set at, what timeline you want it to follow, etc. Now, the benefits of animation worklet, like I mentioned, you get the performance of accelerated animations with the richness of scripted animations. You can use this to then render frame-perfect animations such as custom scroll bar, position, sticky, etc. And if anybody's used web animations, it's basically the same framework, so it's really easy to get started with and get running with. Now, the last Houdini API that I'm going to be talking about is custom layout. Much like custom paint, you would add a module with pointing to a layout file, and then any place that the browser is expecting a keyword value for the display property, you'd pass it a layout callback. Now, on the JavaScript end, you would register the layout class, and you'd have access to a layout function with 3 arguments. The first is the children of the element that you're currently trying to lay out, and then is the constraint space that you need to figure out. So this is the size in which your layout should fit, as well as the style details for the current element that you're trying to lay out. Now, for custom layout, the benefits are basically 2. First of all, you can write your own layout algorithms, and you aren't restricted to the layout algorithm that the browser currently natively ships, which means you can write masonry-based layouts or constraint-based layout. You can also get a lot of performance gains. Browsers currently have to support a large number of layouts because they don't know what kind of layout the website is going to support. By saying that my website is only going to support, say, masonry-based layouts, you can then ignore the browser's native layout system and get a lot of performance gains that way. Now, I've thrown a lot of information at you, but the most important question is Houdini ready yet? Can we actually play with it? And I'm so glad I forced you to ask that question. Silent audience. Now, you can see the status of Houdini APIs across all browsers, as well as the specifications on ishoudinireadyyet.com. It's maintained by Surma, who's DevRel extraordinaire at Google. And here is a screenshot I took on June 1st. Now, you're going to notice that most of the implementations only exist in Chromium-based browsers. However, there are Polyfills out there. And I do ask you that you experiment with these APIs and file feedback not just on the spec, but also on the Chromium implementation. Because in the end, we want these APIs to be performant, robust, and easy to use. And it's only with your feedback that they will be. And with that, thank you so much for your time. You can step away. Amy.
Awesome, good. So, man, we've come quite a far way from jQuery.fade, huh?
Yes. Yep.
Yeah.
Things have evolved so far.
Yeah, it's interesting. You know, we hear a lot of people writing blogs about how they're revisiting web development after like kind of a hiatus, and then they jump into a corpus of knowledge about new things that are being created, and it's like very overwhelming.
Yep.
But then it's also like really exciting because as we're building more ambitious things on the web, we need the web to handle that kind of stuff.
Yep.
Like, you know, we were using like clear PNGs for rounded corners like 6-7 years ago, like not that long ago.
Now you can clip pot them.
Right. It's when border radius came out, I was like, okay, I'm down. I'm gonna. I changed careers actually.
That's good.
And it was border radius. So Houdini has like a task force,
Yep.
and it's people from a number of companies.
Yep.
What's that like?
So I joined Houdini, the Houdini task force, and worked on the Type 2M spec in about 2017, and it's very interesting. Everyone's really passionate about this because, yeah, everyone wants to have to ship less code and get the time to work on their browsers specifically want to go back and say, I'm just going to work on our rendering engine for a bit, make it really performant, and this gives them the time to do so. But yeah, first you have to ship this new set of APIs somewhat unwillingly and then go back. So it's very interesting. The discussions are yeah, everyone wants CSS to be pushed forward, but there's so much to do that this seems like a good way of saying, okay, you go work on these ideas and come back where they're really well thought out, as opposed to we'll hack on them and then later, 3 years later, we'll realize, oh, we didn't alias no wrap properly or something like that, and then it's just interrupt that, then you have to have back compatible. So it's really a good way of thinking ideas through, giving them the time to develop and then implementing them.
So I work at a small company called Fog Creek, and how do people at smaller companies or who work independently get involved in web standards like the Houdini Task Force when they don't have a larger company to represent them? I think a lot about like TC39, where you have to have like $1 million to sit at the table.
Yep.
How do I get involved not in that?
Yep. Without spending all the $1 million because you don't got the dollar cash.
I'm on a tight budget here.
Yeah, that's fair. That's completely
I put
fair.
all my money into these.
Into all these
Just
firms.
kidding. I did not pay for these.
I think a great way to get started is to go to the WICJ, and yeah, if you have just an idea or you just want to give some feedback, like a whole bunch, Focus Visible, I believe it's called right now, its names change quite often in the WICJ, is an idea that a bunch of people started, but then because it's an accessibility API, a lot of people had very strong opinions, and so they went onto the GitHub issue for it and just talked about it, and they gave ideas about how they could be improved, and that's a very low-key way of getting involved. You have zero commitment, you're just getting involved with feedback, and that's the kind of feedback people need in the WICJ. They have an idea, they haven't really thought it through, and so you can also go just fork the repo, upload a little spec that you're thinking about and get feedback. Find the people who you know you want feedback from. It's also much less stress because you can only ask for certain people to come give feedback. And then once you think it's okay, get involved, then you can say, oh, go back, talk to your company and say, I want to kind of get involved in this, go talk to the specific standards committee. And then hopefully at that point you're an expert in this topic and then you can find funding somehow. Not very good at that idea, but I think that's a very low-key way of getting started, in my opinion.
Awesome. So you mentioned polyfills existing. What are some that we should look out for or try out?
So Custom Paint has a polyfill, which I believe Jason Miller just released. He's at Develop It on Twitter, and he's released a Custom Paint polyfill, which is nearly spec compliant. In fact, just one issue missing, so you can go use that. Type 2M had a polyfill, but we had to pull that down, but it is coming back up again, so that's another polyfill that's out there. And then there is work to put up custom layouts polyfill up as well. So they're all nearly getting there.
Is there like any plan to try to have all the polyfills in one central place so I don't have to go out and,
Yep.
Like I could go to Starbucks and have every syrup in a drink?
Yes.
Like, how do I do that with polyfills?
Yeah, there's currently, I think the Custom Paint polyfill is hosted somewhere, and that's good feedback. I think I will go tell them to do that, to put it either in the custom, where the Houdini APIs are, shove them there. That makes the most sense. I think it's while they're still being worked on, it's fine to be in separate places, but then move them. That's actually good feedback.
Yeah, because I think a lot about like Babel, like JS, and how it's sort of just like one-stop shop for compilation.
Definitely,
and all
that's
that.
good feedback.
Yeah, awesome. Thank you so much for your talk and just being part of something that is continuing to promote the open web and keeping it democratized and easy to use. Round of applause.
Thank you so much. Thank you.